Welcome to aminacademy.com. In material science and engineering, let us discuss about Bohr's atomic model. In the year 1913, Niels Bohr proposed an atomic structure model describing an atom as a small, positively charged nucleus surrounded by electrons that travel in circular orbits around the positively charged nucleus like planets around the sun in our solar system, with attraction provided by electrostatic forces. Bohr considered the simplest of all atoms, that is the hydrogen atom. He accepted the Rutherford's model of the atom. According to the Rutherford's model, there is only one electron revolving in the orbit of the hydrogen atom around the nucleus, which is a single proton. Bohr assumed that the electron revolves in a circular orbit. It may be noted that this simple picture of the hydrogen atom is also applicable to some ionized atoms. In the helium atom, there are two electrons, so the removal of one electron from it leaves behind the singly charged helium ion. That is, he proposed, which has only one electron revolving in the orbital around the nucleus, which carries two electronic units of positive electricity. Thus, helium ion resembles the hydrogen atom. In Bohr's model of the atom, the electrons are assumed to be in the definite planetary system in circular orbits of fixed energy. The stationary states are called as energy levels, since there is a definite value of all potential energy associated with each orbit. In this model of the atom, Bohr considered that more than one energy level to be possible for any electron of the atom. Now we'll discuss further. According to Bohr's atomic model, the small positively charged nucleus is surrounded by revolving negatively charged electron in a fixed orbit. He concluded that electron will have more energy if it is located away from the nucleus, whereas electron will have less energy if it is located near the nucleus. The faraway orbit have more energy than nearer to nucleus. Some postulates are proposed. Electrons revolve around the nucleus in a fixed circular path termed as orbit or shell or energy level. The orbits are termed as stationary orbit. Every circular orbit will have a certain amount of fixed energy, and these circular orbits were termed orbital shells. The electrons will not radiate energy as long as they continue to revolve around the nucleus in the fixed orbital shell. The different energy levels are denoted by integers numbers like n equal to 1, 2, 3, 4, like, and so on. These are called quantum numbers. The range of quantum numbers may vary and begin from the lowest energy level, includes side n equal to 1, to the highest energy level. Learn to concept of atomic number. We can understand this concept. Different energy level or orbit are represented in two ways, such that 1, 2, 3, 4 are KLMN shells. The lowest energy level of the electron is called the ground state. The change in energy occurs when the electrons jump from one energy level to another. In an atom, the electrons move from lower to higher energy level by acquiring the required energy. However, when an electron loses energy, it moves from higher to lower energy level. Therefore, we can see first orbit, that is energy level, that is Ground level is represented as K shell and can hold 2 electrons. Second orbit, that is energy level, is represented by L shell and it can hold up 8 electrons. Third orbit energy level is represented by M shell. It can contain 18 electrons. Fourth orbit, that is energy level, is represented by N shell and it can contain 32 electrons. The orbit continue to increase in a similar manner. Electronic distribution of various orbits or energy level can be calculated by the formula 2n squared. Here n denotes the number of orbits. For example, the number of electrons in a K shell, that is first orbit, is equal to n squared, that is 2 into 1 square equal to 2. Then similarly, in the second level, 2 into 2 square, that is second level, equal 8. Like that, third level, 2 into 2 cube equal to 16. Like it goes fourth, fifth levels. Now, some limitation of Bohr's atomic model also there. The following are the fundamental limitation of Bohr's model of the hydrogen atom. Is Bohr's model no longer observes the Heisenberg uncertainty principle. Niels Bohr atomic version speculation considered electrons to have some recognized function and momentum simultaneously. That's unthinkable as indicated with the aid of using Heisenberg. The Bohr's atomic version no longer makes an accurate prediction of large-sized atoms and furnishes enough statistics that are simplest for smaller atoms. Bohr's model does not make clear the Zeeman effect, whilst the spectrum is cut off into some wavelengths in the site of magnetic field. It does not state the Stark effect, whilst the spectrum receives separated into nearly negligible strains in the site of electric powered field. Now we'll discuss further about Bohr's atomic model. One can determine the allowed energy levels by the condition that the angular momentum of the electron moving in a circular orbit, angular momentum, L equal nh by 2 pi. Where n is a positive integer, that is a quantum number, n equal to quantum number. Now, if the transition is from an orbit of higher energy, that is E2, an orbit to the energy E1, that is A1 energy level from 2 to minus energy 1, E2 minus A1 equal Hv. H is a Planck's constant, that is equal Hv equal to E2 minus A1. Now we'll discuss further about Bohr's theory of an hydrogen atom. Bohr's model of the hydrogen atom first proposed the planetary model, but later an assumption concerning that electrons was made. the assumption was the quantization of the structure of atoms. Bohr proposed that electrons orbited the nucleus in specific orbits or cells with a fixed radius. On the basis of above three postulates, that is Bohr's postulates, Bohr first developed the theory of hydrogen atom, which is also applicable to hydrogen-like atoms. The hydrogen atom, that is Z equal to 1, atomic number is 1, is simplest of all atoms, consists of a nucleus with one positive charge E, that is a proton, and a single electron, one proton and one electron. That electron revolving around the orbit of radius r. Proton, that nucleus of hydrogen atom, is inside the nucleus. The centripetal force acting on the electron centripetal force is, we know that mv squared by r. mv squared by r, where r is the radius, v is velocity. The electrostatic force F equal 1 over 4 pi epsilon 0 z e squared over r squared, where z equal to 1, for hydrogen. Therefore, we can say mv squared by r, that centripetal force, is equal z e squared over z e squared over 4 pi epsilon 0 r squared. Now, from Bohr's quantum condition, look here, that is mvr equal to L, which is equal mr squared omega equal to nh over 2 pi, where n equal to 1, 2, 3, 4, 5, 6, like n is integer. Now, therefore, from this V equal nh over 2 pi mr. 2 pi mr equal nh by mr. That means here nh by mr. Now, from this V square, velocity square equal 1 by 4 pi epsilon 0 into z e square over mr, where here h equal, that is h bar equal h by 2 pi, which yields, from this above equations we get 1 by 4 pi epsilon 0 z e square over mr equal n square h square over m square r square. From this radius r, 4 pi epsilon 0 r square over h square by mz e square. This is the radius. We can see that radii of the stationary orbits are proportional to the square of the principal quantum number. Therefore, radius is proportional to square of principal quantum numbers. That is 1 is to 4 because 2 squared, 3 squared is 9, like it goes. Orbit with n equal to 1 has the smallest radius. Therefore, if n equal to 1, therefore orbital radius equal is 0 equal 4 pi epsilon 0 h square over me square, which is by calculation is 0.529 into 10 raised to minus 10 meter, which is equal 0.529 Armstrong unit, which means radius of the orbit of the electron in hydrogen is 0.529 Armstrong unit. Now, like that, we can find the next radius by using n equal to 4, 9, 16, like n equal to 1, 2, 3, 4, like we can get next radii of the electron. Velocity of revolving electron, that is orbital velocity. Orbital velocity V equal Z e square over 2 pi epsilon 0 and H is equal Z e square 4 pi epsilon 0 and H. From this we can write V1 first orbital velocity, that is V1 equal e square over 4 pi epsilon 0 H. By using the values, we can get it is 2.18 into 10 power 6 meter per second, very high velocity. Next, orbital frequency. Orbital frequency, that is omega equal 2 pi V, which is V by R. Therefore, we can see orbital frequency is, after calculation, n z square e power 4 over 64 pi square epsilon 0 squared h cube. By using those values, we can get it is n z square e power 4 over 4 already. I have this one. Obviously, frequency is inversely proportional to n cube. Therefore, frequency is inversely proportional to n cube. N is the quantum number. Energy of electron. Energy of electron. Kinetic energy first is Ek equal half me square, which is equal Z square over 2 pi epsilon 0 r. Therefore, from substituting those values from above, you can get Ak equal mz square over mz equal 4 over 8 epsilon 0 square n square h square. That means we are having more relations. This little complication, but go through carefully, you can get it these expressions. Next, potential energy. Potential energy, that is EP, equal minus AV, which is equal minus ZP square over 4 pi epsilon 0 R. Therefore, total energy is potential energy plus first E kinetic plus E potential, which is equal half m square minus half m square now here you can substitute directly. Ek is Z, which is equal half m square minus Z square over 4 pi epsilon 0 r equal Z square, because it's 8 pi epsilon 0 r minus Z square over 4 pi epsilon 0 r. Then simplifying, we get minus Z square over 8 pi epsilon 0 r. This is a total energy. Therefore, the total energy by calculation, remember the values. Total energy of an electron in first orbit is E1 equal minus 13.6 Z squared EV. This is for second. Second is minus 3.4 into Z squared EV. It goes like. Then third, all our calculation by using the values here. T3 is minus 1.51 Z square EV, like it goes. En, energy at n level is equal to 0 when n goes to infinity. you have done. Please subscribe our YouTube channel.